All right, guys, back to the idea of inheritance. Remember when we were looking at aggregation? Do we have a little picture of it? The aggregation UML shows the relationship of the parts to the whole, right? And those were illustrated with these little lines, right? Where if it's a line with a black diamond, it means that it's a composition, which means that the thing is wholly owned by one object, right? The human body has one brain, and the brain is not shared among two. Or if it was a white line, it could mean that the brain could be shared between more than one person, which would be weird, but, well, you know. See if we can find that picture. Right, so the cars, we're saying that the cars are only tied to one dealership. So the dealership owns the car completely. So that's a composition relationship, black diamond composition. Aggregation means that the salesperson could be more than one dealership, right? And so it's got a white diamond. So that's what the UML looks like for that. That's a little bit of a different UML than what we've seen before, which is where you had the name and then you had the methods and, you know, the items underneath it. So this is showing a composition and aggregation relationship rather than the members and methods of the class. I'm not sure if you can combine those UMLs or not, or if there'd even be any reason to do so. Right, this is a more traditional UML. This one shows the hierarchy of inheritance, the superclass and the subclasses, right? Those look more traditional, right? The name is private here, you know, and there'd be some methods listed under here, and the arrows point up from the subclasses to the superclasses. So within an inheritance hierarchy, the pairs of classes are linked together. For each pair of linked classes, the more generic one, right, the higher one, the person, is called the superclass. And the more specific one, the one that inherits from, is called the subclass. So this is a subclass, that's a superclass. He's a subclass of that one, so that makes him the superclass of that one. And what, does that make that the super class? I don't know. I would call that like the root class or the base class, right? Because it's, you know, the root of everything. So we say that the subclasses are derived from superclasses. We could also say that they extend superclasses, especially if I spell it correctly, right? The reason I like that word is because that's the key word that Java uses. Unfortunately, the term superclass and subclass can be confused, misleading, because super does not mean that it's more capable and that the sub means that it's less capable. Quite the contrary, right? The superclass is the least of them all, right? It has the fewest pieces of data and whatever. And then the subclasses have more data, right? Because this guy has hourly wage and integer and name. So this subclass, you know, is the most capable of all. Kind of the opposite of the names, right? Super, you know, super duper. No, it's not what it means. Super just refers to the positionship, the position of it in the hierarchy, not its capabilities. So we'll stick with the term superclass and subclass, right? Because Sun Microsystems and Oracle decided on that. However, programmers often use the terms parent class or base class rather than superclass, right? So this is the parent class of that, or you could say it was the base class. And you could say that the class below it is the child class, or the derived class. All of those terminologies are great. I'll probably try to stick with superclass or subclass. I may throw in parent class and child class periodically just to kind of familiarize yourself with that, so that if you're talking to somebody else who's been trained in a different discipline, different language, it'll make sense to them as well. Makes sense to you as well. So usually UML class diagrams show the superclasses above the superclass. Common practice, but not a requirement. What is a requirement? The class diagrams use an arrow. The hollow arrowhead points to the superclass, just like that. So benefits of inheritance. It helps with code reusability. The superclass's code can be used for multiple subclasses. You make a really awesome class with a lot of functionality, like the scanner class, and then you may decide that you need a more specific scanner class with even more power. Well, by extending that class, by making a child class a subclass of the scanner class, then you get all the functionality of the scanner class plus even more. So the programmer can use an existing class to easily create a subclass. There's no need to reinvent the wheel. And you can make smaller modules because the classes are split into superclasses and subclasses, right? If all this information, all three of these pieces of information had to be in one, that would be a larger file. Instead, we have 3 files with smaller parts in each one. And it says that smaller modules, says that it makes debugging and upgrading easier. All right, I'll buy that. First time a procedural programmer person who's done, only functions runs into this kind of inheritance business, it may seem more confusing and more difficult to debug and stuff. But once you get the concepts, then you can build really big projects. You can be absolutely sure that a Windows application or an Android application or something like that is going to use inheritance in order to manage everything. So maybe we'll come up with our own example because you can read the person to employee one. I'm going to come up with a silly inheritance. All right, we're going to have a class called critter, and we're going to have subclasses of it. The subclasses are going to be cats. Cats are critters. And raccoons, right? Or cats and fish. Right? Goldfish, something like that, right? This is kind of silly, but whatever. And so every critter has a common trait, right? Every critter will have a name. Every critter will have a preferred habitat, right? Like water or forests or something like that. The cats have their own attributes, right? Whether they are vaccinated, right? You don't vaccinate your goldfish, so we would not make that part of the critter class. So vaccination date, right? Every cat would also have a fur color, right? Goldfish don't have vaccination dates. Dates, not data. Goldfish don't have fur. At least the ones I have don't. They have different information, right? Instead, the goldfish, water temperature, right? His favorite water temperature. And favorite brand of fish food, right? Maybe he likes worms. Maybe he likes, flakes, whatever. What kind of fish food he eats. All right, so we can set this up. We're going to make a critter class, and we're going to make some classes that extend the critter class. Here's what I'm going to do. We're going to go over here. We're on Lecture U. Take away the project. We sing a happy song while we're waiting. Do, 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 do. All right, come on. Come on. All right, so I need those 3 classes, right? I need a critter class and a cat class and a goldfish class. Let's do it. I can minimize these other lectures. I'm on Lecture U in parallel with the Lecture U.java or whatever, in the same package, I'm going to add the critter class. And I don't know why I chose folder. That was a mistake. Right click, new Java class. Critter. All right, here's what I'm going to do, just to be a little bit different. We were talking about making your data private and your methods public. If you're dealing in inheritance hierarchies, you might want to make your data protected rather than private. Private means that the only thing that can access it is that very class. Even the child classes, even the subclasses can't access that data unless you have getters and setters. Protected means that everybody down the inheritance hierarchy can access it. So all the child classes, all the subclasses will be able to access these things. So protected string name, right? And protected string, not strong, string habitat, right? I could add getters and setters for those pretty easily if I wanted to. How do I do that? I've already mentioned this. I could just highlight those guys, choose refactor, encapsulate. The field's visibility is, I need to change that to protected, to preserve it, right? Because I already made it protected here, but encapsulate's trying to make it private. So I'm going to make it protected. But I want the accesses to be public, right? You know, I want main to be able to change the name or whatever. And let's go for it. I'm going to click refactor. And it's going to add all the methods, and it's going to look sloppy. I have all these extra comments. It pushed my fields down to the bottom. I'm going to cut those and move back up to the top and put them back at the top where I think they ought to be, right? I'm going to remove them. And you don't have to do this, but I like doing it. I'm going to make them all in one line, right? Just kind of shortens the class definition if you can do that, right? Don't have to do that, right? And so we have just our normal array of, well, I shouldn't use the word array, our normal set of getters and setters, right? That's a getter, also known as an accessor. And that's a setter, which is also known as a mutator. All well and good. That's our base class. That's our super class. Now we're going to make some classes that inherit that stuff. We're going to make the cat class and the goldfish class. So I'm going to go back to the projects, right click on the default package or whatever package you put your stuff in so that it's going to create another class in the same folder. New Java class. It's going to be our cat. And here's what we need to put. The public class cat extends critter. This means that critter is a superclass. And that cat is the subclass. And he had some extra pieces of information. Right. Let's go look at what the cat class had. A vaccination date and a fur color. I'm just going to make both of those strings. Vaccination date and fur color. See if my short-term memory will hold up long enough. So, public string vaccination date. I'm going to shorten that to vac date, VACC date. Make it slightly easier to type, right? I'm going to initialize that to empty quotes. I should have If I'd been thinking right, I would have done that to critter as well, right? Just initialize it with an empty string or the word default critter and habitat, default habitat, right? And then that way when we created, if we printed something out, if those things have been set, it would not print null, right? Or generate an exception because it was, accessing a null reference. So we're going to say that this one is, I don't know, 00/00/, 1900. Something like that. Okay, that's stupid. How about 1/01/01/1900? All right, that's just the default, right? And the habitat. Public string capital S habitat equals default habitat. I think that's clear. We don't need to say default there. And are we going to add getters and setters for that as well? Yes, of course we are. And more encapsulation. Highlight it all. You can also encapsulate from the context menu by right-clicking. Right-click, encapsulate. Yeah, well, I'm just going to do it from up here. Refactor, encapsulate. I want the field visibility to be protected on the off chance that I make anything that inherits from cats, right? Like Persians or Manxes or something like that. I don't know why I would do that. I'm not planning on it. But I like making my data protected. Even though Jeff's rules of making classes always said private, maybe I'll amend that to private or protected. Same business. I don't like the fact that it puts my getters and setters down here. Excuse me, I don't like the fact that it puts the variables below the getters and the setters. I'm going to paste them back under the opening brace there. Delete some comments. And you saw what I did. I like for all this stuff to be on one line unless there's a strong reason to do so otherwise. And I know I may type faster than you, so you might pause it, whatever. When you do it in this one line format, make absolutely sure you get the semicolon and that is before the closing brace. I've seen people tie themselves in knots trying to figure out the syntax there. You don't have to put it on one line, right? I'm just saying it makes it easier to read. If you disagree, don't do it. All right, so those are accessors and mutators, our getters and setters. Now what I want to do is I want to add a constructor for the critter class. The constructor for the critter class is going to take its name and its habitat. Then I'm going to add a constructor for the cat class. The cat class's constructor is going to need to call the critter class's constructor. Well, why don't we just set that up rather than talk about it? So what is a constructor? It's a method that has the same name as the class with no return type, should be declared public, and it is invoked by the new keyword, right? So, public critter, because no return type, and we're going to pass in a name and a habitat. Name, comma, habitat. Habitat. Both of those are strings, so string name, comma, string habitat. And what does it do? It sets this dot name equal to name, semicolon, this dot habitat equals to habitat, colon, semicolon. I was saying colon for some reason, it's semicolons, of course. Now we could prove to ourselves that this works, right? I could go to main and create a generic critter. Eventually we might make it, not today, where you cannot even create a critter. You can only create cats and goldfish, right? Because maybe it doesn't make sense to create a generic critter. Maybe we only want to be able to create the specific subclasses. I'm going to flip over to main and do that just to show that it works. So I tabbed over to main, clicked over to main, and I'm going to make a critter. Critter CR1 equals new critter. Now I can't do it like that because I added a parameterized constructor, a custom constructor. Meaning that I can't just use parentheses in parentheses anymore, because once you add a parameterized constructor like that, the default constructor is gone. Do we want to add a default constructor so we don't have to do it that way? Yeah, we could. All you have to do is public critter parentheses in parentheses and not do anything, right? Open brace, curly brace, right? Open and close. All right. That way we could, in main, if we wanted to, create a critter like that. But we went to the trouble of making it parameterized. So let's pass in a name, right? I don't know what this critter is. So it's a thingy, right? And its habitat is from outer space. Good enough. Really what I'm interested in doing is checking out the cat class. But we haven't added a constructor for the cat class yet, right? So we're going to go do that. The cat class is going to accept a name and a habitat, but also the vaccination date. And yeah, vaccination date and habitat. Am I duplicating something? Critter had habitat. What did cat have? Fur color. Okay, I goofed that up. All right, I'm going to delete habitat here. You know what, I'm only going to do one thing rather than two. I'm just going to make it vac state. So I'm going to delete every reference to habitat in this. So I only want one method. Excuse me, one member. Same for here. What water temperature does the goldfish like? That'll be the thing we do. All right. So here's what his constructor is going to look like. It needs to be public. His constructor is going to be named cat because the constructor is a method that has the same name as the class. We can make a default constructor like that if we wanted to, but I want a parameterized constructor. Public cat, and it's going to accept a name, so string name. Going to accept a habitat, string habitat, and it's going to accept a vaccination date. String VACC date. So this needs to call the superclasses constructor. So super, right? Or since we already have the name and the habitat, we can pass those in, right? Super name habitat. And then we just have one more piece of data we want to set, right? Because this already sets the name and the habitat. So this dot vac date equals vac date. If I didn't want to do it this way, I could just do it like this, right? I could say super like that, and then I could say this dot name equals, you know, or I could do set name, right? That seems to be giving me an error. Yeah, just give me a little warning. Overridable method call and constructor. Yeah, who cares? All right, I'm gonna ignore that warning, but I want to do it the way I had it, right? We have a constructor that accepts a name and a habitat. Why not do it like that? That's just about enough. Except I really like my variables to be up at the top, and since I put my constructor up top, I'm going to cut these guys, paste them here. So what am I going to do? I'm going to make a two-string method that prints out the cat. Public to lowercase t, string uppercase s, parentheses in parentheses. Then let's build our string. String s equals cat, end quote, semicolon, s plus equals this dot name or this dot get name. Either way would work. Plus, well, yeah, that's enough. But plus a space, right, or a comma, whichever. And then s plus equals this dot, let's get its habitat, get habitat. Since we made these variables protected rather than private, we could be accessing them directly, right? Dot name rather than get name. And then s plus equals the vaccination date, right? We could again do get vac date, or we could just call, dot vac. Except it's not working, right? Vac date, right? Return s. Oh, I forgot to make it public string. That was two string, right? There we go. All right, I think that's good. I think we're good to go here. What do I mean by that? I think that we can create our cat and then print it out. And maybe we want to put parentheses here, right? And then a closing parentheses here, or on the next line. Just to make things look prettier, right? S plus equals, close parentheses. I think I made a curly brace there. Have it. Oh, come on. Quote, parentheses, end quote, right? That's our two-string method, so that we can actually print the object out without having to do a lot of trouble. Remember, you could just make this dot name and dot habitat if you'd like the way that looked better. If those variables had been made private, this would be the only way to get it to work, though, for those two. Alrighty, let's flip back to main and create a cat. Now, since we don't have a two-string method for critter, I'm just going to comment that out. And it kind of proved that it worked, that we didn't have any syntax errors, although I haven't actually built it right. I should have been building it all along, every step of the way, to make sure that I didn't have any syntax errors. Why not? Hammer and broom. Seems to have built. Yep. Let's make a cat. Cat C1 equals new cat. And I'm not going to do it like that because I want to specify all the cool information we can. I'm surprised it didn't pop up information about it. All right. But I know that it'll take Felix. And where does he live? He lives in Cartoonland, Toontown. In case you're a fan of Roger Rabbit, end quote, comma. And what's his vaccination date? I don't even know. He's pretty old, so I'm gonna say that he was vaccinated in 05/01/1923. Right? It's been a long time. He needs to go to the vet, get some new shots. And let's print them out. system.out.println parentheses C1. That'll call the toString method. If it makes you happy to see it, you could type in C1.toString parentheses in parentheses, right? You like that? But you don't need to, right? So let's add a comment. Calls the cat toString method. Let's run it. See what our output looks like. All right, there's our cat, Felix Toontown, and that's his vaccination date. Let's go back to the toString method and make this say just a little bit more information, like name equals Felix, habitat equals Toontown, and that, right? So flesh out our toString method for cat just a little bit, right? He's a cat, and so s plus equals, quote, name equals, end quote, plus, see what I did there, right? Same thing for habitat. Habitat equals, end quote, plus, right? And then vaccination date. Plus, or quote, vaccination date equals, end quote, plus, right? I think that'll make it prettier. Let's run it again and see what we think. Right. Cat name equals Felix, habitat equals Toontown, vaccination equals that. All right. To make it easier for you to do this homework, I'm going to put all the classes in one class. Excuse me, in one file. Yeah. It's against my rules, right? I say that every class should be in its own file. But this way I can post a homework document that just has one file for you to copy and paste and then modify. Because what is your homework going to be? It's to create the goldfish class. So let's do that. I'm going to go get the critter class. And I'm going to have to remove the public keyword. And you don't have to do this to submit it, right? If you're typing it all in. And then I'm going to cut that, go over to the main class in the lecture file and paste it. Right. There can only be one public class per file. That's why I removed the public keyword. So we have the critter class. Underneath it, I'm going to add the cat class. Same business. Right? So I'm going to leave off the word public because you can only have one public class per file, and I'm moving them all to the same file. I'm going to cut that, go back to Lecture U, and paste it underneath critter. Now that's just a matter of choice, right? Java doesn't care what order the classes are defined. I could have put critter at the top, or I could have put, you know, the lecture class up at the top. Whatever. It'll all work. I'd rather put the classes, you know, kind of in the order if you think of them. That's the super class, so I'm putting it on top, right? Super class for cat subclass. All right. Critter is a superclass, cat is a subclass. I'm going to scroll down from top to bottom if you're looking at it and trying to implement it. There's our default constructor. This is our parameterized constructor. Getters and setters. Cat class extends critter because that's how you make a subclass, is with the extends keyword. We have a default constructor. We have a parameterized constructor, a custom constructor, right? And this calls the superclass constructor. toString generates a string so that the class object can be printed. All right. And then the lecture class has a main, of course. I'm going to delete the line about the critter. Makes a new cat. Okay, so homework. Add a new class named Goldfish. It extends the critter class. It has a new member named, what was it named? Water temperature. And I don't care if you make it a string or an integer. Probably may be easier if you made it a string because some copying and pasting would be easier. Your choice though. And give it a parameterized custom constructor that allows the fish to be created like this. Goldfish Nemo, or goldfish F1 equals, I should have just called it fish, right? New goldfish, his name is Nemo. Yeah, I know, Nemo's not a goldfish. His locale is, you know, Pacific Ocean, right? And what's his favorite water temperature? You know, he likes temperatures of 50 degrees. Or if you want to make the water temperature a string instead, you can put quotes around it, right? And then lastly, the goldfish class needs a toString method. So you can print it out with system.out.println parentheses F1, right? Okay, so all you're gonna have to do is take this file, make the appropriate name changes, right? You know, it's not gonna be called Lecture U, it's gonna be called Homework 14 or whatever this is. Add a goldfish class, make it extend the critter class. It's going to look an awful lot like the cat class. All right. If you have any questions over it, please text me. Hope this makes sense. And we will continue to talk about inheritance. It's an important topic. We need to hit exception handling one more time so that after inheritance we can talk about doing cool things like accessing the internet, right? Or making multi-threaded applications. I'd like to spend, you know, the last 2 weeks or whatever doing the really cool stuff.